In this video, we will be discussing the one very famous programming problem in binary search, that is counting the occurrence of a number in a sorted array with duplicates. Okay, we have to use binary. Since there is one rule in a binary, that is we always need a sorted array, right? So we will solve this using binary. Okay, so suppose we have some integer type array and there are some values. Occurrence means we have to count how many times this particular number is there in a array. So suppose 1, 3, 6, and we will 8, comma 8, comma 8, right? Comma 11. Suppose this is our given array, and we have to search some number x, which is currently 8. Okay, how many times 8 is appearing inside this our particular array. So how will we will find, if you remember in previous video we have done what? We have found the first occurrence of a number in array, the last occurrence of a number in array. So we basically what we are going to do, we will reuse that particular code, and we will work and optimize this code for we will tailor that particular code according to our needs. What we'll do, we will first find the last occurrence of a number and the first occurrence of a number. Then we will subtract, okay, uh, first from the last. So we will get our answer. So how can we do that? So let us create uh, one method. Okay, we'll be creating one method called first, which will basically going to take one integer type array uh, and some x, some integer. Alright, once it's one okay. So you know what are the condition of what is the normal binary search look like. So there will be like this properties low, or we can also say it start. So I will just keep write it as low. What then there will be high or a start or end. So low, then suppose there is high, which will contain the last element of an array. Okay. And since we have to store it in something, so we will like create one variable answer. We will store -1 in it. Okay. After that, what we always do, we have to run a while loop. Okay. We have until when we will loop, we will go low is less than equal to 1. Okay. And always what we do in our binary search, int mid. We have to find a mid element. So low plus high minus low to counter the to to counter our overflow. Okay, it is a better approach. Okay, after doing that, we always check if x is equals to what? Array of mid. If it is, what we are going to do, we will set our answer equals to mid. We will store our mid into answer and then we will do high. Now we will be doing, why we are doing high equals to mid minus 1 in that place after storing. So we are doing this because the first occurrence will always be on a left side. So if we do mid minus 1 and we are at this position, suppose, so after doing and we get our mid is this, right. So we already have one variable inside our mid here. Okay, so now there is chances that here on this side also our first occurrence will always lie on this side. So check this side, we will do mid minus 1. So we will now come here, then we will come here. Okay, so let's go. So then we will do else if x is less than, okay, mid. If suppose there is nothing and x would be here, so what we had done then, where we have just repeated the same step, equals to, sorry, mid minus 1. So basically it does the same. It will check on the left side of a array. If uh, x is like greater than a mid, and then what we have to obviously check on the right side. So what it will happen, low equals to mid plus 1. Okay, uh, right, and we will simply return our answer. So since we have written this code, right, so what we can do now, the code will be same for the last occurrence also. So I will just copy it and paste it. First there I will just change it to the last. Okay. After doing that, this condition. Okay. In if, what will be this condition? It will be now we have to check on a if we are checking for last occurrence, it will be always on the right side, right? So low equals to mid plus 1. Okay. This will be the condition. If we do this, so let's call our both function now. So int f first array comma x, we are checking for it, right? And another one f l equals to suppose last uh, pass the array and the x. Okay, now we need occurrence, right? So just print out that. So it will be l minus f. First opening minus 1 and plus 1, because we are using 0 indexing, right? So it will be always like less 1. Okay, if I start to overcome that, we will do plus 1. Okay, so let's run this code right now. Let's see what will be the output. I hope I was clear. You can also do some changes in this code. If you can see, the answer is 4, right? The answer is 4. And how many times 8 is there in our code? Right, 4 times. So if you don't like want to write this code 2 times, okay, suppose I don't want to use this last occurrence thing, okay, so I can, how can make it more like, I will just modify my first function. Okay, so I will do what, I will create one more variable, okay, called boolean and some flag. Okay, so if my flag is true and if my flag is false, okay, so if my flag is false, then what will happen? Any guess? Okay, so suppose this was the condition, right? Only this condition was changing in our both scenario. So we'll basically do what, we'll do this. If our flag is true, so that means we are searching for the first occurrence. Okay, so in first occurrence, what we used to do, hmm, we used to do we used to like assign mix value to the answer. Then we used to do I equals to, right, equals to mid minus 1, right? If the value of boolean is false, that means we are searching for a last opening. So then what we will do, going to do a same first. Okay, we'll store our mid inside answer. Then after that, what we used to do, low equals to mid plus one. So it will going to search for a right half. So where our last occurrence will be there. So if I run this code again, we will going to see that key same answer is there, and we have like cut down the uses of code. So it is like more neat and easy. Okay. So see you in the next one.